Hi all. So in this video we'll discuss some problems based on the block diagram reduction technique. Okay. So the first problem is the reduced block diagram shown in figure 1 and find C by R. That is, C by R means the transfer function. So this is the block diagram G1, G2, G3, H. Two summing points are there and two branch points are there. Okay. So we have to reduce this block diagram. Okay. In the first look we can't find the transfer function from this figure. If we can reduce this block diagram, then we can find the transfer function very easily. Okay. So for reducing we have to use some block diagram reduction techniques. Okay, so here we can see that a branch point is taken from here. That is, it is clear a branch point is taken from here. Okay, so if you can move this branch point ahead of this block G, okay, if you are moving this branch point ahead of this G, so we will get a symbol loop here and a symbol loop here that we can see here. That is, if you can move this branch point to this point, okay, if you are moving this branch point from this point to here, okay, what happens? So we know that if we have to move a branch point ahead of the block G, okay, head of the block G, what was the rule? This is the rule. Okay, branch point ahead of the block G, so we have to add a 1 by G in the line. Okay, so likewise if you are moving this point, okay, if we are moving this branch point ahead of this G1, we have to add what? A 1 by G1. Okay, a 1 by G1 in this line. So we can see here, we have just moved the branch point here, so we have added a 1 by G1 in the line. That is, in the line of G3 we have added a 1 by G1 here. Okay, 1 by G1. So we can see that we have made the loops independent. Okay, this is a symbol loop and this is a symbol loop. Okay, before it was a complex loop. That is, this is a loop, but we are taking a branch point from here, so we can't solve the block. Okay, we can't replace this entire block with a symbol block. Okay, with a single block. So for making it simple, we are just moving this branch point over here. Okay, so we know that we can simply replace this block with, this is the 1 by G1 into G3, so it becomes G3 by G1. Okay, in the next diagram we can see here it will become G3 by G1, and here, so this is a negative feedback loop. We can see it G1, and we are taking the output and again feedback to the negative portion. Okay, that is the input. So based on the rule we can simply replace this negative feedback loop. Okay, this is the loop, we can feedback loop as G1 by 1 plus G1H. Okay, G1 by 1 plus G1H, just to have written here G1 by 1 plus G1H. Okay, and here it becomes G3 by G1, and we know that both the direction of the two signals are same. Okay, both the directions are same, so we can simply add these two signals here. That is G2 plus G3 by G1. We can simply replace this entire block with a simple block G2 plus G3 by G1. Okay, so G2 plus G3 by G1 is coming in series with the G1 by 1 plus G1H. So we know that we can combine these two blocks as this one into this one. Okay, so the transfer function C by R will be this value into this value. So G1 by 1 plus G1H into G2 plus G3 by G1. So at last become G1 G2 plus G3 by 1 plus G1H. 1 plus G1H. Okay. So likewise we can we can simply solve the equations. Okay, so all the block diagrams. Okay, G1 G2 plus G3 by 1 plus G1H. So this is the method we have to follow. If we are getting a block diagram like this, we have to think about the transitions. What is the easiest way to solve this block diagram? Okay, we have to observe it carefully. Okay, and one more thing I am remembering, that is, normally we will not exchange the summing point with this branch point. So it is very important. If you are just exchanging this summing point with this branch point, okay, so if you are moving the summing point ahead of this branch point, it will be very difficult to solve. Okay, so the system becomes more and more complex. So normally we will not move the summing point, we will not exchange the summing point with the branch point. Okay, and all other transitions we can do, that is, the branch point can be moved before a block, and the block can be moved before a summing point, like that. Okay, so this is the method we are following here, and the last output is E bar is g1 g2 plus g3 by 1 plus g1h, 1 plus g1h. Okay, and the next problem is, using the block diagram technique, find a closed loop transfer function of the system whose block diagram is shown in the figure. So it is a very large block diagram. Okay, so we have to find some methods to reduce the block diagram, and we have to find the C by R, that is C of S by R of S, Laplace transform of output by Laplace transform of input, that is transfer function. Okay, so for solving this block, okay, just we have to observe the block thoroughly. Okay, here we are having a loop, but there is a branch point here. Okay, if we can move this branch point over here, we can simply solve this block, and no other simply solved blocks are there. So we have to do some transformations, just exchanges here. So first step is, we are going to move this branch point before this block G2. Okay, before this block G2. Okay, so in the next figure you can see that we are moving this here, this branch point before this G2 here. So we know that based on the rules, if we are moving a branch point before the block G2, what we have to do, that is, if you are moving this branch point before this G2, we have to add a block G2 in the same line. Okay, in the same line. So if you are taking a branch point from here, we are getting a signal multiplied with G2. Okay, if you are moving this point before this G2, the signal will not get a chance to multiply with this G2. So we have to add a G2 in this line. So you can see here, we have just moved the point here. From here we have just moved the point, and we have added a block G2 in the same line. Okay, so in the next step we can simply combine these two blocks as G2 G1, G2 H1. Okay, G2 H1, and so this loop becomes G2 G3 plus G4. Okay, so we can simply combine these blocks. Both the directions are same. This is not a feedback loop. Both the directions are same. So we can simply add these values together. Okay, so in the next figure we can see that G2 G3 plus G4, and this becomes G2 H1. Okay, so this is the next figure, G2 G3 plus G4, and this becomes G2 H1 G2. And next, what you have to do here. Okay, so here you can see that if you are moving this summing point, okay, if you are moving this summing point before this block G1, okay, we are going to move this summing point before this block G1. Okay, because we have already done a transformation here, and we will obtain signals like this. Okay, but here it is a loop, here this is a loop, but there is a branch point. We are taking a branch point from here. Okay, so if we can move this branch point before the summing point, we can simply solve this block. But I have already said that the exchange between the summing point and a branch point, okay, will lead to the problem become more difficult. Okay, so normally we are not doing that. So we are going for another option. Okay, so we are just moving this summing point before this G1. Okay, so this block this summing point will come here. Okay, so for moving a summing point before this G1, what we have to do, that is we have to just look the rules. That is, if you are moving a summing point before the block, okay, if you are moving a summing before the block G, just we have to add a 1 by G in this line, in the line B. Okay, so likewise here, so in our problem we are moving a summing point before this G1. Okay, so we have to add a 1 by G1 in this line. Okay, in this line, so we are adding a 1 by G1 in this line. Okay, so we know that if two summing points come together, there is a chance for interchanging. Okay, there is a chance for interchanging. Okay, that is by observing the figure, the loops are like this. Okay, this is a loop and this is a loop. Okay, so if we can interchange these two loops, okay, interchanging these two summing points, the figure will be like this. Okay, we can simply get two independent loops. Okay, that is this comes here and this comes here. Okay, so that is this summing point along with this h1 g2 comes here. Okay, so g1 h1 g2 and this summing point, we can simply get a simple loop, feedback loop here. Okay, so this becomes g1 into g1 h1 g2 is here, and another feedback loop is here. Okay, so first we can replace this loop with g1 by 1 plus g1 h1 g2. We know that, and the feedback loop, a negative feedback loop, can be replaced by the g by 1 plus gh. Okay, if g is the forward function and h is the feedback gain, we can simply replace it with g by 1 plus gh. So here g1 is the forward gain and h1 g2 is the feedback gain, so it becomes g1 by 1 plus g1 h1 g2. Okay, g1 by 1 plus g1 h1 g2. Okay, and this block, okay, we can replace this block here. Okay, so it becomes this g1 by 1 plus g1 h1 g2 is here, so we can simply multiply this value with g2 g3 plus g4, that we can see here. Okay, we can simply combine these two blocks. Okay, instead of this feedback loop, this comes here, so this into this one will give this block. Okay, so the entire large block becomes a small loop here. Okay, and the feedback gain is h2 by g1. h2 and 1 by g1 are multiplied together to it becomes h2 by g1. Okay, so we will get again a feedback loop like this. This is also a negative feedback loop. Then again we can use our function g by 1 plus gh. So here g is this value. Instead of this g, this value comes. So instead of this h2 by g1 comes. So this value divided by 1 plus this value into this value. So that we can see here. Okay, this value divided by 1 plus this 1 into h2 by g1. Okay, so we are just simply cancelling some terms, and at last we will get it as g1 g2 g3 plus g1 g4 divided by 1 plus g1 g2 h1 plus g2 g3 h2 plus g4 h2. Okay, so instead of this feedback loop, we can replace with this block. Okay, so we can see later. So this is the loop here. Okay, we are just simply replacing this one with this one. Okay, so a block comes here and a feedback loop having a gain of 1. Okay, this is a feedback loop having a gain of 1. No h1 h2 like that, no any terms are here, so the feedback gain is 1. Unity gain feedback, we can say it as a unity gain feedback. Okay, so again we can use our function g by 1 plus gh here, because this is a negative feedback loop. So g by 1 plus gh, so g becomes this and h becomes 1. No feedback gain is there, so this function divided by 1 plus this into 1. Okay, that is this function divided by 1 plus this function. So at last we will get as C by R is equal to G1 G2 G3 plus G1 G4 divided by 1 plus G1 G2 H1 plus G2 G3 H2 plus G4 H2 plus G1 G2 G3 plus G4. Okay, so this is the last transfer function we are obtaining. So I hope you understand the block diagram reduction well. Okay, practice some problems. So here there is a problem I have put here. This is a figure. So we have to find C of S by R of S from this block diagram. We have to use some block diagram reduction techniques, and based on that we can simply find the transfer function. Okay, all of you just do it. So thank you very much.